Okay, so today we're going to look at multiplication, division, and estimation with real numbers. And we're going to start by using some previous techniques that we've seen in earlier sections and just see how it works when we throw fractions into the mix and how to interpret that sort of thing. So the first skill we're going to look at is called the repeated addition model, as we now are experts at this addition concept. So let's say I take 3 times 3/4. In the addition model, that means I'm going to be adding 3/4 together 3 times. And we've already got rules that dictate how to add common denominators or denominators that aren't alike, and we can just apply those here. So here I've got 9/4, and then I can convert that into a mixed number of 2 1/4. We can do that same problem again. But this time we can take advantage of the area model. So again, using repeated addition, I'm going to look at 3 of these little circles. I should make some decent effort to make them similar sizes. Okay, so I've got 3 sets of 3/4. Okay, and so I can collect up all those pieces, and it looks like they would form let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, sorry, 3, 4, 5, 6, 7, 8, 9. So I can see that 3 times 3/4 is the same as 2 1/4. So I can visually make that connection. Okay, so that's all great if we have whole numbers, but what if we're looking at fractions? So let's take something like 1/2 times 3/5. Okay, so let me first create 3/5. One more. Okay, so there's 3/5 would be that piece, that piece, and that piece. Those 3 out of 5. And now I want to look at half of that. So half of the 3 pieces would be those little chunks there. But now how many pieces have I split this thing into? Well, now I've got 10 of them, and I've shaded 3 of them. Okay? And so 1/2 times 3/5 would be 3/10. Okay, so that brings up what we define then to be multiplication. So after working with several models, hopefully students can generalize that to variable sense and can just deal with what do we do with physical numbers when we see them without having to draw pictures the whole time. So the rule is if I have 2 fractions that I'm multiplying together, I'm going to multiply the numerators and multiply the denominators. Okay. So for example, 2/3 times 3/8, right? That would translate into 6/24. And then we could remind ourselves of reducing rules and recognize that, oh, that's right, I can divide out 6 from each and end up with 1/4. Okay, but there's some other properties that we can remind ourselves about as far as dealing with multiplication. So let me just kind of go through a couple of them with you. We have the multiplicative identity property. All right, so let me spell that out here. Multiplicative. Okay. And what that says is that there exists a number 1. Now, we understand that's what 1 does. You multiply 1 by something, you get that same number. But the multiplicative identity property says there has to exist a number that has that connection. So there exists a number 1 such that 1 times a over b is the same as a over b times 1, which is simply a over b. So that there has to exist this number that when I multiply by something, I don't change the value of the number. Okay, there's also the multiplicative inverse property. Okay, says for any non-zero rational number a over b, there exists a multiplicative inverse or what we would call the reciprocal, which in our case is b over a, where a over b times b over a gives us 1. So there's this nice relationship between the multiplicative identity and the multiplicative inverse. So the inverse says there has to exist some fraction that undoes the original fraction and leaves us with the multiplicative identity. Now, let's kind of practice a little bit of this. All right. What would the multiplicative inverse be for 2/3? That would be 3/2. And then what would the multiplicative inverse be for -2/5? And that would be -5/2. Let me kind of write that these are multiplicative inverses, because we also have additive inverses that we've talked about in a previous section. So what would the additive inverse be for 2/3? And that would be -2/3. And the additive inverse of -2/5 would be +2/5. Now notice those are the vocab is very close. It's very close together. The fact that you have inverses in both. One of them you're looking at a reciprocal though, and one of them you're looking at the opposite of the original number. So it's very easy for students to get those two concepts confused. Okay, so let's look at some ways that we can teach students how to multiply mixed numbers together. So let me give us 2 numbers to stare at here. So we'll just do 2.5 times 2.5. There's kind of 2 main methods to do this task. Method 1 is to convert to improper form. Okay, so 2.5 would be 5/2. So this would convert the problem into 5/2 times 5/2, which is 25/4. And then I could convert the improper form into the mixed number form. So 4 goes into 25 6 times. So that's 6 1/4. The other method to do this, so method 2, would be the distributive property method. Now again, the intention here is not to show you, I'm not assuming you don't know how to do this. I'm saying let's look at techniques on how to do this. Okay, so with the way the distributive property works is I'm going to rewrite 2.5 as 2 plus 1/2 times 2 plus 1/2. And then I'm going to distribute like terms. So that'd be 2 times 2 plus 1/2 plus 1/2 times 2 plus 1/2. All right, so in the first set, I have 4 plus 2 times 1/2 would be 2 over 2 plus 2 over 2 plus 1/4. And so that's 2 over 2 reduces down to 1. So I get 6 1/4, which matches the same answer we got. And again, the point isn't, I'm not asking you this because I doubt whether or not you can do it. We're looking at these methods to help students kind of see different ways to go about doing it. Okay, so let's talk about division, and again, let's start with some nice concrete models. Let me start with 3 divided by 1/2. Okay, so what that means is I need to take 3 wholes, 3 numbers, or 1 plus 1 plus 1, and I want to divide that into equal groups of 1/2 each. So I essentially want to cut up the 3 into halves. And then I want to count up how many halves there are. And so that would be 1, 2, 3, 4, 5, 6. So I was able to get 6 equal groups of 1/2 built into 3. Okay. Let's take a look at a number line. So let me generate a number line here, going out to 3. 0, 1, 2, 3. Okay, so 3 divided by 1/2 again says that I'm going to go 1/2 out. So 1/2, 1/2, until I get up to 3. Okay, how many groups of 1/2 was I able to get? I was able to get 6 of those. Okay, so that brings us to a nice formal definition of division. And